If you've been watching my channel for very long, you may realize that I operate a retail firearms outlet. In fact, it's one floor above me. And I have a lot of good friends and customers. And one of them, Bill, knew I did this sort of stuff, and he said, do you want this? He said, I got it. I don't know where it came from, but you can have it. Anytime you see a knob like this on a piece of free electronics, take it. This thing weighs 12 pounds. It has the big knob, an on and off switch. There's a broken fuse holder here, red light, and an ammeter goes up to 5 amps. This was made by a company called Precise. At least that's a stick-on label. And it's to vary the speed of a universal motor. Now, a universal motor is a series wound motor. That is, the stator and the armature are placed in series. And because the armature is rotating and the stator's not, the connection is made through brushes. A motor of that type with brushes can be powered with AC. And the speed of that motor can be varied by varying the voltage. This big knob with the pointer on it has a scale calibrated in hundreds of RPMs, with this being 1500, 2000 or 2000, 3000, 4000, 4500 RPM. Today, a handheld drill motor is almost always variable speed using solid-state devices built into the handle, and your finger controls the speed. In the 50s, 60s, 70s, and 80s, that wasn't such an item that was available. The only way those motors could be varied is with some variable voltage device. I think we'll be surprised or very satisfied when we get this open. Anyway, it's got a solid steel case, nothing on the back, the underside. Well, there's feet on the underside. And there's an AC outlet on this side. A permanently attached line cord. I cannot make out the model number, but somebody has written it here. I don't know if this is correct or not. And it says it will operate up to 1/2 horsepower high-speed spindle. Let's take it apart. Something's got to give here. The outlet was fastened to the side. There were, get them down here so you can see them. The line cord comes in and has a couple of 1/4-inch push-on tabs. They were pushed onto the top of these lugs on the power switch. And then a couple of green wires, this one, this one, got to be 4 pounds in this case. And the power cord ground attaches here to this ground lug. And of course the case is all welded together. The nut on the ground lug is actually painted green. This is Stanco Electronics auto transformer. You can see the windings. They go out here around sort of a toroid. Around, it's round. The insulation is exposed here, and rotating the big knob causes this tap, it's a rotating tap, to move along the coils. Underneath the wiring here, you can see 3 screws and a little pointer type indication that tells me this screw here is the rotating tap here. An auto transformer is a transformer with just one winding. And the way a normal auto transformer works is, let's say between here and here we had 120 turns. We apply 120 volts. That gives us 1 volt per turn. 120 volts, 120 turns. So if I move this slider up and down using this as a reference, I can actually increment in 1 volt steps the whole way up to 120 volts. If we attach or build in 20 more turns, total of 140 turns, apply 120 volts across 120 of the turns, gives us 1 volt per turn, and I can increase the output voltage by moving the tap clear up to here to 140 volts. So I could use this as a step down transformer or a step up transformer by varying the position of this tap. Now, we saw some taps, well, we saw some terminals when we looked at this transformer. Right now, the AC power is applied between, well, let's identify these taps. We know we have a total of 5. 1, 2, 3, 4, 5. And that 2 and 4 are connected together, as evidenced by this little, oh, it's hidden. Take this off. See this white line connecting 4 and 2. So let's identify these taps on the drawing. Tap 1 actually occurs there. Tap 2 and 4 occur here and here. Tap 3 is the variable tap. And tap 5, which is not used currently, is this tap. So right now, taps 1 and 2 receive the input voltage. So 120 volts is being applied between 1 and 2. The output voltage is taken between 2 and 3. So I should be able to provide 120 volts in and get 0 to 120 volts out. And we'll take a look at that. Alright, it's powered up. The pointer is at approximately mid position. And I'm getting 62.4 volts. If I rotate the big knob the whole way around, I get 124 volts, give or take. So this auto transformer is wired to provide essentially a half a volt midway, the whole way up to 123.6, say 124 volts. Can't tell it maybe, but the power light is on. I'm going to unplug it. I don't like to work with this hot. And you can see the light extinguished. Voltmeter went to 0. That's with power applied here and here. So with power applied between 1 and 2, the output voltage can never exceed the input voltage. I'm going to move the input voltage from terminal 1 to terminal 5. So the input voltage now is 1 to 2. I'm going to change that to 5 to 2. Okay, I powered it up once again. With the pointer at midpoint, now I get 75 volts. If I go the whole way up, I get 150 volts. You can see the pointer's clear visible over here. And I'm getting 121 volts. There I'm getting approximately what I'm inputting. Let me power this down for a second. And you can see where the knob is. So right now, the tap is right here, just opposite 5. And the output is equal to the input. This remaining tap is accessible from here to here. So what this does, with the input changed to from 1 to 5, it gives me a 5-amp outlet that outputs a voltage adjustable from essentially 0 to 150 volts. And that can be pretty handy to have in the shop.